Okay, let's try some more fencing word problems. We have 1,200 feet of fencing. This is y, this is y, this is y, and this is x, and across we have x as well, going all the way across. What is the maximum area? And we have two equal areas, regions, here and here to the left and right. So what can we say about perimeter? The perimeter of the fencing is 1,200. So perimeter is equals to 2x plus 1, 2, 3y. That's our first equation. Our second equation is area. The maximum area is x times y, base times height. Given two equations, we can do it. We're going to replace y with the y up here. So we're going to throw 2x over. We get 3y is equals to 1,200 minus 2x. So therefore y is equals to, we're going to divide this by 3. 1,200 divided by 3 is 400. And 2x divided by 3 is just 2x divided by 3, negative 2/3 x. So now we're going to substitute this y value here. So the formula is area is equals to x times 400 minus 2/3 x. Let's feed the dog. We get negative 2/3 x squared, and let's feed the cat, plus 400x. And as you can see, this is a side face parabola, and you can attack the vertex by setting x equals negative b over 2a. This gives us the x value of the vertex. So even without using Desmos, we can do it. This is our a value, this is our b value. So x is equals to negative b over 2 times the a value, which is negative 2/3. 2 times negative 2/3 is negative 4/3. And so when you're taking this number, negative 400 divided by negative 4/3, this is the same thing as negative 400 multiplied by the reciprocal. This is going to be 3 over negative 4. The negatives cancel. 400 divided by 4 is 100. 100 times 3 is 300. So we have x equals 300. So we type this equation to Desmos, and you can see that indeed the vertex has an x value of 300, and the maximum area is 60,000. If you really want to solve for y, you can do so, because we have the x value. All you have to do is look for the equation involving y and substitute x here. But the original question is just to find the area, and we found it. To find this 60,000, all you have to do is plug in 300 into the area formula here. Let's work on this similar but slightly different question down here about the barn. You have 300 meters of fencing, and we want to find x and y to maximize the area of the yard. So this x value only goes across this far. It doesn't actually go all the way across. But we want to maximize the area of the yard. Let's think about the fencing. The fencing only goes around here, not including the barn. It's not necessary to have a fence right by the barn. So the perimeter, which is 300, is equals to x plus 2y, there's a y here and there's a y here, plus this width here, which happens to be x plus 60 more, which is up here. So this is x plus 60. So we can simplify this. You can see there's an x here and an x here. So this becomes 2x plus 2y. And this positive 60, we're going to throw it all the way to the left, which becomes a negative 60. 300 minus 60 is 240. And we're allowed to divide both sides by 2. So we have 120 is equals to x plus y. So this is our first equation. And the question is talking about maximizing the area of this yard. So the area of the yard is a rectangle, is base times height. The area is not x times y, no, the base is x plus 60. X plus 60 times y. So let's replace y and speak the same language of x. Let's use this first equation. So we have y is equals to 120 minus x, and we're going to substitute into here. So the area is equals to 120 minus x multiplied by x plus 60. So just for fun, rather than just foiling this out, I'm going to pull out a negative 1 just for practice. Let's pull a negative out and see what happens. This gets reversed when you use distribution, it's the same thing. And we can see the factors of the quadratic. And by knowing the factors, the negative sign means it's a sad face, concave down. We immediately know the roots, the x-intercepts. So instead of plus 60, we have minus 60 here, and there's a x-intercept or root here. Instead of minus 120, we have 120 over here. So the quadratic will roughly do something like this. So even visually, we know the halfway point. We simply add these numbers and divide by 2. So 120 added with negative 60 is 60, divided by 2 is 30. So x equals 30 is the equation of the line of symmetry. It's also the x-coordinate of the vertex, the maximum. If you really want to expand it out, you could and use the vertex formula. So let's do that. Let's go up from up here. First, area is equals to 120 times x is 120x. Outside, 120 times 60 is a large number, 7,200. Inside, negative x squared. And last, we have negative 60x. So the area formula is also negative x squared. We have 120x minus 60x is plus 60x plus some large constant. And we know that the equation line of symmetry is x equals minus b over 2a, which is minus 60 over 2 times negative 1. So 2 negatives cancel, we have 30. And as you can see, our previous technique also gives us the same answer. And now that we have x, we simply have to substitute to figure out y. And the question is asking us to find x and y. So y is equals to 120 minus 30, which is 90. And if you really want to find the area, you just have to plug in x into here. Okay, so now it's your turn. You have 3 equivalent pens, and you have 600 meters of fencing. What's the maximum possible area?